Hello, good morning dear students. Today is 28th. So in the last video we have completed till question number 10. Alright. So now we're starting with question number 11. And the question goes like this. If integrate this function 1 by 2x minus 3 whole to the power 3 by 2 dx. Okay. So we don't have any option rather than doing substitution. And what will I substitute is, let us substitute this expression 2x minus 3 as p. So if I substitute and then take the differentiation with x, dp by dx will be equals to 2. Okay, so dp by dx equals to 2. But see, I just have to find the value for dx, isn't it? So the value for dx will be dp by 2. So till here. Okay, so we got the value for dx. So therefore integral I becomes 1 by, the value for this is p, isn't it? So 1 by p to the power 3 by 2 into dp by 2. Right? Now 1 by 2 is a constant, so 1 by 2 is a constant, and integration of this is p to the power minus 3 by 2 into dp. And now you know what to do. Use the formula, and while using the formula and solving the powers, you'll be getting p to the power minus half divided by minus half, isn't it? This and this gets cancelled out, 2 gets cancelled out, so minus half. Bring it down in denominator, 1 by 2x minus 3 to the power half plus c, which is the final answer. So pause the video to note down. Okay, next one is number 11 part 2. In question number 11 part 2, the question is integration x divided by 2x minus 3 dx. Here also we have to make substitution, and the substitution is the denominator again. Let us assume p is equals to 2x minus 3. So on doing so, we'll get the value for dp by dx. So dp by dx equals to 2. So the value for dp will be dx will be dp by 2 again here also. So this is the value for dx. And now if I put the value for I is equals to out here, if I put in this out here expression, capital I will be, this is integration. Now see, the value for p is 2x minus 3. So from here, what is the value for x? P plus 3 divided by 2 is equals to x, isn't it or not? You tell me, is it a value for x in terms of p? Because see, the whole integral has to be in terms of p now, isn't it? So this is the value for x, p plus 3 by 2. So therefore integration, therefore the integral becomes I is equals to integration. The value for x is p plus 3 divided by 2 into 2x minus 3. What is the value for 2x minus 3? P into dp by 2. Okay, so therefore this is integration p plus 3 by 2p into dp by 2. So 2 to the 4, 1 by 4 is a constant. Integration p plus 3 divided by p into dp. So pause the video to note down. Yes, so this was a step now. So what we need to do now, we need to simply split term by term. P by integration of p by p plus integration of 3 by p. Okay, which is this. So 1 by 4 was a constant. So while separating, you'll be getting integration of dp plus 3 integration of 1 by p dp. Okay, so integration of dp is p plus 3 integration of 1 by p is log p plus c, and finally put the value for p. The value for p plus p was 2x minus 3. Okay, so pause the video to note down. Okay, next one we move to question number 12 part 1, which is 2010 question. I see capital I equals to integration x divided by x plus 1 whole square dx. Here also let us substitute the denominator, that is x plus 1, not whole square, just x plus 1. So p is equals to x plus 1 is a substitution, and from here dp by dx is equals to 1, isn't it? So dp is equals to dx, and from here we'll also find the value for x in terms of p. P is equals to x plus 1, so x equals to p minus 1, isn't it? This is the value for x. It is same as question number 12 part 2, isn't it or not? Sorry, 11 part 2. So therefore the integral becomes, in place of x, p minus 1 divided by x plus 1 means p, so this is p square into dp. Okay, so pause the video, we'll move to the next step. Yes, which is this, and now we can split term by term. P by p square, isn't it? That is 1 by p, and minus integration of 1 by p square, which will be p to the power minus 2, and then simplify, use the formula, this is log p, use the formula x to the power n, and finally putting the value for x. So pause the video to note down. Okay, now further moving, we'll move to question number 12, part 2. But before that, let us understand this concept properly. Any fraction, okay, any fraction can be written as quotient plus remainder by divisor. Any fraction. Example I've taken out here, 7 by 2. Okay, 7 divided by 2. It is a fraction, isn't it? 7 is an integer, 2 is also integer, positive integer. So it is a fraction. So this fraction can always be written in this form. This fraction can always be written in this form. This fraction is equals to quotient plus remainder by divisor. So you divide out here 7 by 2. So when you divide, 2 3s are 6 and 7 minus 6 is 1. So hence 3 is my quotient, isn't it? 1 is my remainder and 2 is my divisor. So hence if I write in this form, then this will be 3 plus 1 by 2. 3 is quotient, remainder 1 and divisor is 2, isn't it or not? So pause the video to understand this. Right, so any fraction is always equals to quotient plus its remainder divided by divisor. The reason I've explained this is out here, we'll also try and use the same concept out here. Even though it is not actually a fraction, these are called rational functions, okay? We'll come to that later in the other exercise. But this is very, very important for us right now. So here we have x square plus 2 divided by x plus 1. Okay, here I cannot do substitution directly also. Even if I do substitution directly as x plus 1 as p, there will be some other complications. Okay, so by not doing substitution, what we can do is I can write this in the form of quotient plus remainder by divisor. So let us divide them. Let us divide x square plus 2 by x plus 1, which I've done out here. So x plus 1 divides x square plus 2. Obviously it's x times. You know how to divide it. Divide it, you find the quotient, you find the remainder, and this is the divisor, isn't it? So hence I can write out here this fraction as numerator by denominator is equals to, this is my quotient and this is my remainder and this is my divisor. I hope you are clear till here. So pause the video to note down. Quotient plus remainder by divisor. This is quotient Q. Quotient plus remainder by divisor. So pause the video to note down. So you also have written, so this was the integral given to us, integration x square plus 2 divided by x plus 1. We divided, we use the formula quotient plus remainder by divisor, isn't it or not? So hence I can write this as quotient was x plus remainder was this and divisor was this, isn't it or not? So hence if I separate integration x dx plus integration 2x minus 2x by x plus 1 into dx, which I'm keeping it equation number 1, I can evaluate x square integration x, which is x square by 2, and I cannot integrate this directly, so I'm keeping it as I1. Now I'll find the value for I1. Now I know I1 means this, isn't it or not? According to assumption, I1 means this. So what to do again use the same method out here by substitution. Assume the denominator as p, solve, the entire thing is same. So just pause the video to note down, you'll just understand this. Just nothing is there, just make an assumption, you're opening the brackets and finding the integrals. This is the value for I1, okay? There's no problem in finding the value for I1. I know you people will understand. And put this value for I1 back in equation number 1. Okay, this was equation number 1, isn't it? The equation number 1 was I is equals to x squared by 2 plus I1, isn't it? So put the value for I1 out here. So this is the value for I1. We are putting the value for I1 out here. Okay, last one more thing. This is the value for I1, isn't it or not? This was the value for I1. But in your answer, we'll only see minus x. There's no plus 1. You'll only see minus x. The reason it is only minus x is because C, we know capital C is a constant. C is a constant and even plus 1 is also a constant. Okay, this thing is very important. Don't get confused in the answer at the back. Yeah, final answer is actually this only, but if you check your answer at the back, there is only this one. There's no plus 1. The reason is that plus 1 is a constant and C is also a constant. So constant plus constant is another constant, which is C1 out here. Okay, so pause the video to note down. So if you're clear with that question, that was question number 12 part 2. So now I'm moving to question number 13 part 2. 13 part 1 is similar, you can do yourself. 13 part 2, we have a polynomial, okay, divided by binomial x plus 2. Right? We have a polynomial divided by binomial x plus 2. Again, let's use the same method, division method. So by dividing, I'll be getting the quotient, remainder, and divisor. This is my quotient, this is my remainder, and this is my divisor. Just simply by dividing, we know how to divide it, isn't it or not? The whole process is out here. Quotient plus remainder by divisor. So integration of this, we are making the form of integration, quotient plus remainder by divisor. So what is the value for quotient? Quotient is this, x square plus 2x minus 7 plus remainder 12, and divisor is x plus 2. Now split it term by term. Integration of this plus integration of this, which is this, and here also I can split it term by term. Integration of x square plus 2 is a constant, integration x minus 7 constant, integration of this plus integration of dx divided by x plus 2. Okay, so therefore if you integrate it properly, this will be x cubed by 3, 2x squared by 2 minus 7x plus 12. Straight away you can write this as log. We know integration of 1 by x equals to log x. So integration of 1 by x plus 2 will be also log x plus 2. Right? So therefore, this is your final answer. Also, some questions I have written out here. It is same as question number 14 is same as example 6 part 4. Please refer to the example from the book. Question number 15 part 1 is same as example 7 part 3. Question number 15 part 2. Use the hint. I've written the hint out here and show the method and show the process, few steps. Proceed with this steps. Okay. So pause the video to note down. So from this exercise, we'll keep till question number 15 part 2. Right. From this exercise, we'll keep till 15 part 2. Some of the hints I've given out here for question number 14 and 15. Okay. So pause the video. Go through the questions properly and the hints as well and the examples as well. Okay. So now we move to exercise 8.4. Now exercise 8.4 also, it is same as 8.3. We just have to make substitutions, and the substitutions is right there in the question itself. Okay. If you practice it properly, I'm telling you, this exercise are going to be very, very easy for you all. You just need to practice it properly. Huh? Okay. Exercise 8.4, question number 1. We'll be only doing a few sums from this exercise. Okay, in today's class. Exercise 8.4, question number 1. Capital I equals to integration x cube, within the bracket I have 1 into 1 plus x to the power 4 whole cube, isn't it? Now look at this expression, 1 plus x to the power 4. I know if I assume this as p and differentiate, then I'll be getting 4x cube, isn't it not? Is it? 1 plus x to the power differentiation, 4x cube. So I'm getting x cube somewhere, isn't it? So therefore, start with the assumption again. So p equals to 1 plus x to the power 4. Differentiated, you'll be getting dp by dx equals to 4x cube, isn't it? Now I need to find the value for x cube into dx. I need to find the value for x cube into dx. So dx is out here. Cross multiply it and bring your 4 down in the denominator. So dp by 4 will be equals to x cube into dx. Simple calculation. P differentiation, and I'm finding the value for x cube into dx, which is dp by 4. Now what should I do? Put back the values in capital I. Therefore capital I will be, the value for this is p. So is it p cube? P cube into x cube into dx. X cube into dx, the value is dp by 4. dp by 4. Put the value. Simple form is we are getting. We know how to integrate this. P to the power 4 by 4. 16. Put back the value for p, which is 1 plus x to the power 4. Finished. So pause the video, understand it. Any doubt, any queries, you can ask me. Alright, the next question is question number 1 part 2. The question is right there. Integration 2x plus 4 root over x square plus 4x plus 5. Right, here also we have to make substitution. Now you focus on the expression which is inside the square root, x square plus 4x plus 5. What happens if I differentiate this with p? X. First let us assume this as p. Assume this as p and differentiate. So what is the differentiation of x square? 2x. What is the differentiation of 4x? 4. So therefore I am getting 2x plus 4. Differentiation of 5 is already 0. Doesn't matter. Okay. So hence if I substitute and differentiate, then I am getting the expression outside. isn't it or not? But remember, this expression is inside the square root. So when I make a substitution, I'll have to write it as not only p but p square, since it is inside the square root. I hope you're clear now. Okay, so assume this as p square. So p square equals to x square plus 4x plus 5. P square equals to x square plus 4x plus 5. The differentiation is same. Okay, you'll find the value for 2x plus 4 into dx. You'll find the value for 2x plus 4 into dx. You'll find the product of this. So 2x plus 4 into dx is 2p into dp. Therefore, this is p square. So root over p square into 2x plus 4 into dx is 2p into dp. Square it gets cancel out. So therefore, 2 into integration of p square. We know how to integrate. Here, now the last point out here, till here it is fine. So 2 by 3 into, see this is p cube plus 3. What is the value for p? What is the value for p from here? So the value for p will be root over x square plus 4x plus 5. This is the value for p. Okay, so put back this value for p out here. So it is p cube. So but p is this. So put the value for p out here, that is root over x square plus 4x plus 5. This is the value for p and whole to the power 3 plus c. Maybe in your answer it is 3 by 2 because it is square root, and we know square root means to the power half. So half into 3 will be 3 by 2. It doesn't matter. Okay, you can write in this form, or if you want to write in the same form as you answer at the back, you can also open the square root and write to the power half, and half into 3 will be 3 by 2. Okay, so pause the video to note down. And last but not the least, the assignments for today. Okay, a similar kind of questions I have given from this exercise. 2 part 1, assume p as x square plus 2. 2 part 2, assume p square because there is a square root. Wherever there is a square root, you have to assume it as p square. Number 3 part 1, assume this as p. P equals to 3x square plus 2x minus 5. Please read the questions and properly. Number 3 part 2, since there is square root, p square. Okay, so that's it for today. Then I'll see you in the next class. Thank you.